In this video, we will be discussing game theory, and more specifically, three-player simultaneous and sequential move games. Here we have a problem where three firms are deciding whether they should enter a new market, and they ask us to find Nash Equilibrium and any dominant or dominated strategies. And so we are given a game table for three players, which looks like two different game tables, but it ultimately comes down to player 3's decision and is a standard game table for players 1 and 2. And as we can see, if all three firms enter the new market, they each earn 45 as their profit. If only two firms enter the market and one firm does not enter the market, the firms that entered the market will earn 85, and the firm that does not enter the market will earn 0. And if only one firm enters the market, the firm that enters will earn 100, and the firms that do not enter will earn 0. So when it comes to finding Nash Equilibrium in a three-player game, it is done very similarly to finding Nash Equilibrium in a two-player game. It just involves extra steps. So if I was to use yellow to represent firm 1's decision, and using my strategic foresight, I can then figure out which decision firm 1 will pick depending on firm 2 and firm 3's decision. So starting if firm 2 were to enter and firm 3 were to enter, firm 1 would decide between 45 and 0, as these are the first number and represent the first player. And as we can see, 45 is the bigger number. Firm 1 would go with 45. And if firm 2 was to not enter and firm 3 was to enter, firm 1 would decide between 85 and 0 and see that 85 is the bigger number. So firm 1 would choose to enter if firm 2 decided to not enter and firm 3 decided to enter. Continuing, if firm 2 were to enter the market and firm 3 chose to not enter the market, firm 1 would decide between entering and not entering, and as seen as 85 is the higher number, firm 1 would enter. Now, if firm 2 were to not enter and firm 3 was to not enter, firm 1 would decide between 100 or 0, and as we can see, 100 is bigger than 0, so firm 1 would choose to enter. And since firm 1 always chose to enter, it can be seen that firm 1 has a dominant strategy of entering the market, and firm 1 has a dominated strategy of don't enter the market. So now if we were to move on to firm 2's decisions, and we would use green to represent firm 2's decision, we would then look at things a little bit differently. So we would compare the second number in the left to right between each row. So if firm 1 was to enter and firm 3 was to enter, firm 2 would decide between 45 and 0, and seen as 45 is the bigger number, firm 2 would choose to enter if firm 1 enters and firm 3 enters. Now if firm 1 decided not to enter and firm 3 decided to enter, firm 2 would decide between 85 and 0 and see that 85 is the bigger number and decide to enter. Continuing, we would see if firm 1 were to enter and firm 3 was to not enter, firm 2 would decide between 85 and 0 and see that 85 is the bigger number and decide to enter. And if firm 1 decided not to enter and firm 3 decided not to enter, firm 2 would compare 100 and 0 and see that 100 is the bigger number and decide to enter. And as we can see again, firm 2 has a dominant strategy of enter and a dominated strategy of don't enter, as they always chose to enter and never chose to not enter the market. Now we will look at firm 3's decisions, and this is where things get a bit different, as we would compare between the two tables of outcomes to see which would work best for firm 3. So, for example, if firm 1 decided to enter and firm 2 decided to enter, firm 3 would look at this 45 right here and this 0 right here between the two different tables in the same spot. So, as we can see, firm 3 would choose 45 as it is the bigger number than 0, and then we would continue on for each individual box. So if firm 1 decided to enter and firm 2 decided to not enter, firm 3 would decide between this 85 and this 0. And as 85 is the bigger number, firm 3 would decide to enter. If firm 1 decided to not enter and firm 2 decided to enter, firm 3 would decide between this 85 and this 0. And seeing as 85 is the bigger number, firm 3 will decide to enter. Lastly, firm 1 is deciding to not enter, and firm 2 is deciding to not enter, so firm 3 would decide between this 100 and this 0. And as the 100 is the bigger number, firm 3 would decide to enter. And as we can see, firm 3 decides to enter every single time, so this makes it firm 3's dominant strategy, thus making don't enter firm 3's dominated strategy. So they will always want to enter the market and never want to not enter the market. With this information, we can find our Nash equilibrium. Which is then the most likely outcome, which is enter, enter, enter. And if we were to write the associated payouts, it would be 45, 45, 45. And as discussed before, the dominant strategy for each firm would be to enter, and the dominated strategy for each firm would be to not enter. Next, they ask us to find Nash equilibrium and any dominant or dominated strategies if firm 1 were to move first, followed by firm 2, and then lastly by firm 3. So as we can see, this is very similar to a sequential move game for 2 players with an extra layer added on, and as a result, more options. So how we want to solve for Nash equilibrium involves some more strategic foresight, meaning we would find firm 3's most likely outcome based off of the options firm 2 were to choose. Firm 2 would make a decision based off of firm 1's decision, and firm 1 would choose the option which seems the most likely to earn them the highest profit. So as such, we can act as firm 3 and decide which option works best for us depending on what firm 2 decided. And since we're firm 3 and we move last, we would be looking at the last number of each one. So if firm 2 were to enter, firm 3 would decide between entering and not entering, which leaves either 45 or 0 respectively. And since 45 is a bigger number than 0, we can eliminate don't enter as an option for if firm 2 was to enter and if firm 1 was to enter. Now if firm 2 was to not enter, if firm 1 were to enter, firm 3 would decide between 85 and 0 on entering or not entering respectively. And since 85 is a bigger number than 0, firm 3 would not enter. And if firm 1 were to not enter and firm 2 was to enter, firm 3 would decide between entering and not entering and earn either 85 or 0 respectively. And since 85 is a bigger number than 0, firm 3 would choose to enter, eliminating don't enter as an option. And lastly for firm 3, if firm 1 was to not enter and firm 2 was to not enter, firm 3 would be deciding between 100 and 0. And since 100 is a bigger number, they would choose to enter, thus eliminating don't enter as an option. And as we can see, firm 3 has a dominant strategy of enter and a dominated strategy of don't enter, as they always choose to enter and never choose to not enter. Next, firm 2 would be making a decision based off of what is left. So as we see, there are 4 options left, and firm 2 would be making a decision depending on each option and what firm 1 decides to do. And so if firm 1 was to enter the market, firm 2 would decide between entering and not entering and would look at the second number for each box and compare between the 2 options. So if firm 1 was to enter, firm 2 would look at this 45 and 0 and see that 45 is the bigger number, So firm 2 would decide to enter and eliminate the option of don't enter. Now if firm 1 was to not enter, firm 2 would decide whether to enter or not enter, and thus decide between 85 and 0. And since 85 is a bigger number than 0, firm 2 would choose to enter, thus eliminating the don't enter option for firm 2. So, as we can see, there is yet another dominant strategy and dominated strategy where firm 2 would decide to enter always and never decide to not enter the market always. Lastly, we have firm 1's decision based off of the strategic foresight used to find the likely outcomes for firm 2 and firm 3. So, firm 1 only has to decide whether or not to enter or not enter based off of the first number. And seeing as 45 is a bigger number than 0, firm 1 would decide to enter, thus eliminating don't enter as an option. And as such, we find our Nash equilibrium to be enter, enter, enter. And this is the same Nash equilibrium as the simultaneous move games. So there is not a first mover's advantage. So by moving first, firm 1 does not earn anything more than firm 2 or firm 3, and thus earns the same associated payouts of 45 for firm 1, 45 for firm 2, and 45 for firm 3. So as we can see, 3-player game theory is very similar to 2-player game theory, it just involves a few more extra steps. That will conclude this video on 3-player game theory.